It was impossible to adjust the top slide so that it would be both firm enough to maintain accuracy and avoid chatter, while at the same time being free enough to move easily. The best that could be achieved was loose through the centre of its travel and binding up at either end. The reason is because it's warped. Not worn, but warped. The whole piece of cast iron is warped, higher in the centre and lower at either end. I'd hazard a guess that the crash damage on the front edge has something to do with that. The plan to remedy this is to skim the bottom face, as you can see here. This will create a flat bottom, but the gib will still be tightening against the curved dovetail slot, so a dovetail cutter is used to clean up the dovetail slot. There isn't really a downside to making the overall dovetail shape wider, as the slide mechanism is adjustable. The combination of flimsy setup, cheap dovetail cutter, and run out from the 3-jaw chuck make this a precarious operation, but it all went smoothly enough. The next job is to clean up the edges of the top slide. They were mushroomed over from years of use, and you can clearly see the crash damage on the front edge of the top slide. Now, I can't really tolerate a massive crater in my top slide, so I'm going to fill it with weld. The correct way to weld cast iron is with cast iron filler rod, but that's a major hassle, although I do have a project coming up where I will show that process. But for this, what I'm going to do is the impossible: weld cast iron with standard MIG wire. This is one of those things that everybody knows can't be done, but if you fire molten metal into a pool of molten metal, stuff tends to stick. Steel into cast iron is not a perfect mix, and there will be small defects in the weld, and I wouldn't suggest this for a mechanically stressed repair, but for filling holes or maybe repairing the foot of an old clawfoot bath, it works well enough. This always happens. Run out of gas. I quickly heated the top slide, just to burn out embedded oil. The surface of cast iron is effectively slightly porous, and holds on to oils even if the part has been thoroughly cleaned. In the case of a frying pan, that's great, but not so much for welding. You can see the transition between steel and cast iron. There are also a number of bubbles throughout the weld, but these defects are mainly on the side faces, which will be painted. My point is, don't be too shy to try. Despite the fact that this is not the proper way to do this repair, the end result is perfectly adequate.
Which I create is not part of me, and I cannot feel myself as part of that product.
Next, I skim the top face of the top slide to clean up the surface and also to make sure that it is parallel with the machining carried out on the bottom. As with all parts of this project, there were plenty of marks and dings that needed smoothing out. I think my smooth file has been the most used tool on this project. I'm not sure if you can get this zinc paint in other parts of the world, but it is my go-to primer for all things black. I use it for undercar components. It dries rock hard and the zinc content actually does what it says on the side of the can. Total overkill for lathe parts. The surface can be a bit fluffy, so I overcoat it with black Rust-Oleum, normally semi-gloss, but in this case full gloss. The top surface of the cross slide shows years of dings and scratches. Anywhere there's a dent, there will be a corresponding high spot, so I carefully run a file across the surface to knock these down, and along the edges just to clean things up. If I had access to a surface grinder, or convenient access to a full-size milling machine, I'd skim the top back to a nice clean machined face, just for appearance reasons. But this piece is critical to the accuracy of the lathe, so I won't attempt to repair what is only cosmetic damage with anything less than a proper setup. To compensate for skimming the bottom of the top slide, I'll superglue a couple of strips of brass to the underside. The only reason this is necessary is because the little BA nuts that lock the top slide adjuster screws are really close to the bottom, and now they will catch on the base, so this brass is really just packing to lift those clear. And as per in the last video, I coarsely sand the surface of the brass to allow space for oil. The bolt that comes up through the top slide to hold the tool post has a little trick to it. There is a small pin that goes between the two. The pin is just long enough that it can line up the two before the bolt itself catches in the top slide. There are 3 small screws that apply downward pressure on the collar of the bolt to counter the lifting action of the tool post itself. It seems like a slightly clumsy arrangement, but that's the way they did it.